A UBC Okanagan research team has created a computer modeling program to help scientists predict the effect of climate damage and eventual restoration plans on coral reefs around the globe. But, because they are so complex, it's logistically challenging to study the impact of devastation and regeneration of coral reefs. Needless to say, conducting experiments that will disturb natural coral reefs is unethical and should be avoided, while using big aquariums is simply unfeasible, says Dr. Carturan, who recently completed his doctoral studies with the Irving K. Barber Faculty of Science. For these reasons, no such experiments have ever been conducted, which has hindered our capacity to predict coral diversity and the associated resilience of the reefs. For his latest research, published recently in Frontiers in Ecology and Evolution, Dr. Carturan used models to create 245 coral sea. By running so many scenarios with computer modeling, the team found that more diverse communities, those with species having highly dissimilar traits, were most resilient. They were better at recovering from damage and had greater habitat quality 10 years after the disturbances. More diverse communities are more likely to have certain species that are very important for resilience, Dr. Carturan explains. These species have particular traits, they are morphologically complex, competitive and with a good capacity to recover. When present in a community, these species maintained or even increased the quality of the habitat after the disturbance. Coral species are the foundation of coral reef ecosystems because their colonies form the physical habitat where thousands of fish and crustaceans live. Among those are herbivores, such as parrotfish and surgeonfish, which maintain the coral habitat by eating the algae. Without herbivores, the algae would kill many coral colonies, causing the coral habitat to collapse, destroying its many populations. What is unique with our study is that our results apply to most coral communities in the world. By measuring the effect of diversity on resilience in more than 245 different coral communities, the span of diversity likely overlaps the actual coral diversity found in most reefs. At the same time, the study provides a framework to successfully manage these ecosystems and help with coral reef R. Looking forward, there are other questions the model can help answer. For instance, the coral species vital for resilience are also the most affected by climate change and might not be able to recover if strong climatic heat waves become too frequent. Thanks for watching. Please subscribe my channel for more videos.